Okay. So now, in the last class we discussed that every square matrix can be expressed as a symmetric plus skew symmetric. So we just recall that note. So we have the, when you are doing that, we have the two matrices. P is equal to A plus A transpose by 2. Q is equal to A minus A transpose by 2, where P is a symmetric matrix, P is a symmetric matrix, Q is a skew symmetric matrix. Skew symmetric matrix. This we discussed yesterday. So here these two formula important. P equal to A plus A transpose by 2, Q equal to A minus A transpose by 2. This we will use while doing problems. This is a P formula and this one is a Q formula. Okay, we need these two when you are doing problem. So now we'll come to the question. Express the following matrix. The following matrix. Express the following matrix. Sum of symmetric and skew symmetric matrices. Skew symmetric matrices. So given matrix you have to express as a symmetric plus skew symmetric. So the matrix is a 4, 2, minus 3, 1, 3, minus 6, minus 5, 0, next minus 7. So this is a given matrix. This matrix you have to split into two matrices, P plus Q format. So we have to split into P plus Q. Okay. So now solution. So 4 2 minus 3, 1 3 minus 6, minus 5 0, minus 7. Solution. Given matrix. We do one thing, we write solution in the next page. Solution. Given matrix. Assume it as a A. So given matrix you assume as a A. So A is equal to 4, 2, minus 3, 1, what we taken? 1, 3, minus 6, 1, 3, minus 6, next minus 5, 0, minus 7. So this is a given matrix. Then what you have to do means you find A transpose. A transpose means write rows into columns. So 4 row as a column, 4, 2, minus 3, next 1, 3, minus 6, second row as a second column, minus 5, 0, minus 7, third row as a third column. So now you got A transpose. Now we have the formula P equal to, so what is the formula? P is equal to A plus A plus A transpose by 2. Okay, this is the formula. So now 1 by 2 into this 1 by 2 right outside A plus A transpose. Okay, wait a minute. 1 by 2 into is there, 1 by 2 into A matrix. What is the A matrix? 4, 2, minus 3. Next, 1, 3, minus 6, minus 5, minus 5, 0, minus 7. Next, plus 4, 2, minus 3, 1, 3, minus 6, 5, 0, minus 7. Next, A transpose. A transpose. We need little big bracket. 4, 1, minus 5, 2, 3, 0, minus 3, minus 6, minus 7. Okay, 1 by 2 into this one. So matrix addition. So 1 by 2 into matrix addition. 4 plus 4. 4 plus 4. Next, 2 plus 1. Next, minus 3, minus 5. Next, 1 plus 2. This one, 1 plus 2. Matrix addition. Next, 3 plus 3. Next, minus 6 plus 0. Next, minus 5 minus 3. Next, 0 minus 6. Okay. Next, minus 5, minus 7 minus 7. Matrix addition. So now 1 by 2 into 1 by 2 into 4 plus 4 8, 2 plus 1 3, minus 3 minus 5 minus 8, 1 plus 2 3, 3 plus 3 6, minus 6, minus 5 minus 3, minus 8, minus 6, minus 14. So I'll try to multiply this 1 by 2 inside. Wait a minute. The next page. We'll come to the next page. So I'm trying to multiply that 1 by 2 inside. 8, 3 minus 8, 3, 6 minus 6, minus 8 minus 6, minus 14. So now is equal to that 1 by 2 inside. We have to multiply to each and every element. 8 by 2, next 3 by 2, next minus 8 by 2, next 3 by 2, next check it, 3 by 2, 6 by 2, minus 6 by 2. So 3 by 2, 6 by 2, minus 6 by 2, next
Minus 8
minus
by
8
2.
by 2, very good, minus
Minus
6
Minus
8 by
6
2.
by
minus
2. Minus
minus.
14 by 2.
Minus 14 by 2.
14 by 2.
So every time to see back page, it is a little complex for me. Okay, now 8 by 2. 8 by 2 is a 4. Next 3 by 2.
3
Next minus
minus
4. Okay, when I ask, then you give. Uh, Later I'll try to upload these videos in the YouTube also. 3 by 2. 6 by 2, what's value? How much? 3. Next minus 6 by 2, minus 3. Next minus 4. Next minus 6 by 2, minus 3. Next minus 14 by 2, minus 7. So this is a P matrix. So we know already in the theorem we proved P is a symmetric. So where no need to check, we already proved in the theorem. So where P is a symmetric matrix. Okay, so now listen here, one more symmetric how we can check means without doing any process, just whatever the row is there in the same way column, check it. 4 3 by 2 minus 4, column also 4 3 by 2 minus 4. So check the second row, 3 by 2, see second row, 3 by 2 3 minus 3, 3 by 2 3 minus 3. Okay, like that we can check directly, no need to doing A equal to A transpose. Check the third row, minus 4 minus 3 minus 7, minus 4 minus 3 minus 7. Therefore P is a symmetric. So no need of checking, we are proved in the theorem already. Therefore it is a obviously symmetric only, whatever P got, that is automatically symmetric, no need of checking again. So you got P matrix. Okay, from this P we got. In the next page, now what we'll do means we'll go for the Q. You know Q is equal to formula A minus A transpose by 2. Okay, so now 1 by 2 into, I'll put flower brackets. You can put any of your brackets. 1 by 2 into A. What is the A matrix? We'll come to the starting page. Uh, what is A matrix?
4,
4
2,
2 minus 3. 4 2 minus 3, 1 3 minus 6, minus 5 0 minus 7. 4 2 minus 3. Next
1, 3,
1 3 minus 6.
1 3 minus 6.
minus
Next
5, 0, minus 7.
minus 5 0 minus 7. Very good. Everyone alert while going class. It's a very nice. So now you got A. Next minus A transpose. So when you come to the A transpose, you can, what is that? 4 1 minus 5, 4 1 minus 5, 2 3 0 minus 3 minus 6 minus 7. If any remember, it is a good. So A transpose, what is it?
4,
4
1,
4 1
minus
minus 5.
5,
2,
2
2
3,
3
0,
0, sir.
minus
Minus 3
3.
minus 6 minus 7.
3 minus 6
Okay.
minus 7.
Okay, very good. So now listen here. A matrix is a 4 2 minus 3 1 3 minus 6 minus 5 0 minus 7. A transpose is a 4 1 minus 5 2 3 0 minus 3 minus 6 minus 7. I return this from the given data. I'm not doing any other thing. Just a return from the given. A given A transpose we have. Next, or you can directly 4 2 minus 3 you write in the column here. No need to see back also. A is there. It's a transpose means 4 2 minus 3 you write in the column. So now we have to do subtraction. 4 4 minus of 4 minus 4. Next 2 minus 1. Next minus 3
Plus 5, sir.
minus 3
5.
minus of minus 5. I'll write one step to understand everyone in the class. Next 1 minus 2. Okay. Next 3 minus 3. Next minus 6 minus 0. Next mute. Who is that? Mute, please. Minus. When I say respond, then only you do. Minus 5 minus of minus 3. To understand everyone, I am writing one step extra. Next 0 0 minus of minus 6. Okay, 0 minus of minus 6. Next minus 7 minus of minus 7. So this is nothing but wait a minute. This is nothing but what its value? 1 by 2 into 1 by 2 into 4 minus 4 0, 2 minus 1 1, minus of minus plus 5, minus 3 plus 5 2,
2,
next to 1 minus 2 minus 1, 3 minus 3 0, minus 6 minus 0 minus 6, next minus of minus plus 3 minus 5 plus 3 minus 2. Okay, next minus of minus plus 6. Next, minus 7 minus of minus plus 7. So what its value? 0. Is there any doubt? Can anyone respond?
No, sir.
No, sir.
Okay, very good.
No, sir.
Now,
No, sir.
now I'll try to multiply this 1 by 2 inside. I will do that in the next page. What you got? 0, 1, 2, minus 1, minus 1, 0, minus 6, minus 2, 6, 0. So in the next page, I'll multiply this 1 by 2 inside. It is a good is equal to 0 by 2, okay, 1 by 2, next
2
2
by
by
2.
2
2 by 2, wait a minute again,
minus
what is it? Minus
1
1,
by 2
0, minus 6, minus 1 by 2, 0 by 2, next minus
minus
6 by 2,
by 2
mute lo పెట్టండి,
minus
wait a minute, next minus 2 by 2, next 6 by 2, minus 2 by 2, 6 by 2, next 0 by 2, okay, so now, so that is nothing but its value is a 0, 1 by 2, 2 by 2 value 1, minus 1 by 2, 0, 2 ones are 2, minus 3 is a minus 3, minus 1, 2 ones are 2, 3 is a, okay, next is 0. You got Q matrix. This is a which value? Q. Check it. This is nothing but Q. We did process for Q. So now you got Q is equal to. No need to check. This Q is a skew symmetric. We already discussed this in the theorem. So no need of checking. That's the reason yesterday we proved the theorem. Why? Because every time no need to check whether Q is a skew symmetric or not. Obviously it is a skew symmetric. Where Q is a sorry where Q is a skew symmetric matrix. So now here we obtained two matrices. One is a come here, uh, the P matrix. You got one matrix is a P. Our target is to find the two matrices. One is a P. You got this highlighting. It is a P. Okay. Next you got other one. That is nothing but Q. Sorry, this is nothing but Q. Wait a minute. Somebody entered. So this is a P matrix, this is a Q matrix and P matrix. So by theorem we know that this P and Q are the symmetric and skew symmetric matrices. So what is the question is saying? Express the following in terms of symmetric plus skew symmetric. That we have to write. So now we'll come to the next page. A is equal to P plus Q. A is equal to P plus Q, where P is a symmetric, Q is a skew symmetric. Okay, so now we have to write that values. What is the P? Just now we are calculated P. So this is your P. That P you have to write. P equal to 4, 3 by 2 minus 4, 3 by 2, 3 minus 3, minus 4 minus 3, minus 7. Okay, can anyone remember this rows? 4, 3 by 2
yes,
minus
sir.
4,
Yes, sir.
4,
3
3
by
by
2 minus 4 3
second,
by 2
3 by 2,
3
3
minus 3
minus 3, next
minus 4
minus 4,
minus 3
minus 3,
minus 7
very
Minus 7,
good,
sir.
very good. So next Q matrix. Wait a minute, we go back. Q matrix. What is a Q matrix? 0, 1 by 2, 1, minus 1 by 2, 0, minus 3, minus 1, 3, 0. 0, 0, 1.
1 by 2,
What is
1.
it?
1 by
By
2, 1.
2, 1.
1.
Minus 1
Minus
by
1
2,
by 2,
0.
Minus 1 by 1 person. Minus 1 by
0.
2, 0,
Minus 3.
minus 3,
Minus 1,
minus
3,
1,
0. 3,
minus 1, 3, 0. Very
0.
good. So this is a matrix. So my interest is I will write question also. Why? Because what I did, I want to be know. Actually, PQ finding is enough, but what we did, I want to be know that clearly. So we'll come to the question. What is the question? A is equal to what is that? 4 2 minus 3, 1 3 minus 6, minus 5 0, minus 7. That we will write here. Then you will get the clear picture what we did. So A is equal to 4 2 minus 3. Next 1 3 minus 6. Next minus 5 0 minus 7. Question I have. Okay, so now this is a matrix. A is expressed as a P plus Q, where P is a symmetric, Q is a skew symmetric. That means our solution is completed. Given matrix, we are splitted into two parts. One is a symmetric and another is a Q symmetric, P plus Q. So any question, it is a one question you may get in the short answer or 5 marks. Express the following matrix in terms of symmetric, skew symmetric means simply you have to find the p value. Simply you have to find the p value and q value, and you have to write like this. Finding PQ must. After finding, it is better to write like this. Why? Because what we did, what is our target, you have to know carefully. Most of the people, what they will do means they just find the PQ, there they can close. It is a good, but we have to show what we did. A is a given matrix. That given matrix we are split into two matrices. One is a P is a symmetric, Q is a skew symmetric. Okay, this completes the solution. Okay, now have any doubts? Can anyone respond?
No, sir.
No,
Okay.
sir.
Sir.
Is a crystal clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
this is about the how the given matrix splitted into symmetric and skew symmetric. One question you can expect in the final exam. So like this, you can solve any type of problem. Given matrix, just a P formula, Q formula. Remember always this P formula, Q formula. P, what is the P formula? A plus A transpose by 2. A plus A transpose by 2. What is the Q formula? Q formula is A minus A transpose by 2. This is a Q formula. Okay. So based on this, we can find the symmetric and skew symmetric. This completes the solution. Now, can I move to the next topic?
Yes, sir.
Can anyone say what is the time now?
10:13, sir.
10:13. That means the class completed 10:45. No? Okay, we can go for
Yes, sir.
next. Okay, next. Next one is also one important topic only. Important means one like a symmetric, skew symmetric. How? In the same way, other topic is a orthogonal matrix. Last symmetric, skew symmetric, and this orthogonal matrix. From these two, one question compulsory. Orthogonal matrix. So now we are going to define what is a orthogonal matrix. Wait a minute. Have any doubts, you can feel free to ask. And now I'm going to define the definition of the orthogonal matrix. Definition. A square matrix capital A. What is a square matrix means? Can anyone?
Rows and columns are equal.
Same number of rows
Equal
and
to number
columns.
of columns.
Yes, same number of rows and columns. Now,
Columns.
based on a square matrix capital A is a square matrix. A is a square matrix. We will write like this otherwise. Definition: a square matrix, capital A. This is our matrix. Capital A is said to be orthogonal matrix. Is said to be orthogonal matrix. Is said to be orthogonal matrix if A transpose equal to A transpose A is equal to identity. That means when you multiply A into A, you have to get identity. In the same way, A transpose into A also you have to get identity. If this is a happens, A transpose and A transpose A, both of them values are identity matrix, then we say this A matrix is a orthogonal matrix. Whenever given matrix A, what you have to do means you find A transpose, multiply it. If the values are identity matrix, then also find A transpose into A. First to do A transpose, check it identity or not. Next, again find A transpose A, check it identity or not. If both are identity, then given matrix is a orthogonal matrix. Have any doubt on this?
No, sir.
No, sir.
Little more deeply, I want to be discuss one more point here. For example, first we'll come to the numerical, then you will get some picture about what I am going to say. What is in my mind? For example, 2 into 1 by 2, its value will be 1. 2 into 1 by 2, its value will be 1. 1 by 2, 2 into 1 by 2 equal to 1. 1 by 2 is a what? Can you comment? Can anyone?
Rational number.
Not that. Yes, I want that. Rational, but I want, what do some boy said? Inverse. 2 into
Multiplicative inverse.
2 into 1, yes. 2 into 1 by 2 equal to 1. Therefore, 1 by 2 is the inverse of 2. Next, or 2 is the inverse of 1. 2 is the inverse of 1 or 1 by 2 is the inverse of 2. When you get right side 1. In the same way, it is in the numbers 1 is identity. In the numbers 1 is identity. In the matrices, I is an identity. So now when you do A transpose, A transpose equal to identity, can you say what is a transpose equal to? What you can say about A transpose? Can anyone?
1 by A.
You say, for example, what I'm saying is 2 into 1 by 2 equal to 1. Therefore, 1 by 2 is the inverse of 2. 2 is the inverse of 1. So, now
A to the
can you
power
say,
minus.
wait a minute, you just give the sentence, A into A transpose equal to identity. Therefore, A is a
Inverse
what?
of A transpose.
Inverse of A transpose.
Okay, so A is a inverse of A transpose, or A transpose is a inverse of A. You can say in any manner. 1 by 2 is the inverse of 2, or 2 is the inverse of 1 by 2. So therefore, A transpose equal to identity, we can say A inverse is a A transpose, or A transpose inverse is a A. So another way how we can write means, which implies A inverse is equal to A transpose.
A transpose.
So listen here. After this, we can extend our thought. What is the orthogonal definition? A transpose equal to identity. Now onwards, you can say when A inverse equal to A transpose, then also orthogonal matrix. This is a basic definition. A transpose equal to identity. A is an orthogonal matrix. Not only that, if A inverse equal to A transpose, then also A is a orthogonal matrix. So in the when in the question asks what is a orthogonal matrix means, you write A transpose equal to identity, or you can say A inverse equal to A transpose, therefore A is a orthogonal matrix. So definition you can mention this one, or this one. We derived from our knowledge. Second one. This is a given basic definition. So definition means you can write this one or this one. Or you mention both, it is a very good. Okay, now onwards, orthogonal matrix means A transpose equal to A transpose A equal to identity. There's a one way. Other way, A inverse equal to A transpose, then also A is also orthogonal matrix. Have any doubt on this? Can anyone?
No, sir.
No. Based on this, I'll try to do one problem. Wait a minute. I'll take some fraction type problem. Then it is a okay. So now question. Now we are going to do the problem on orthogonal matrix. Okay. Verify that given matrix is orthogonal or not. Verify the given matrix is orthogonal or not. So what is a given matrix means? Given matrix 1 by 3 next to 2 by 3 next to 2 by 3 next to 2 by 3 next to 1 by 3 next to minus 2 by 3 next to 4 by 3. Sorry, this is not 4 by 3. Wait a minute. 2 by 3. Okay. Next, minus 2 by 3. Next, 1 by 3. Wait a minute. I'll check the question one more time. 1 by 3, 2 by 3, 2 by 3, 2 by 3, 1 by 3, minus 2 by 3. 2 by 3 minus 2 by 3, 1 by 3. So when you are doing the matrices, you alert that once you check that you are given your whatever your written problem. Why? Because majorly when you are doing matrices, we simply make some minus plus. One minus plus can change the problem. Okay. So now this is a given matrix. This given matrix we have to check whether it is a orthogonal or not. Okay. Now listen here. Solution will start from your solution. We'll put here minus 1 by 3. So now solution, let this A is equal to, assume this matrix is a A. So now this matrix you have to check whether it is orthogonal or not. Orthogonal or not means you have to check A transpose equal to identity or not, you have to check. So now before that what I'm doing means take the, what is the common in this all elements? What is the common?
1 by
1
3.
by 3.
So to make simple, I'm taking 1 by 3 common. In the matrix you can take common when it is present in every element. In every element is a present, then only you have to take common. So 1 by 3 present in the every element. So I'm taking 1 by 3 outside. So now 1, 2, 2, 2, 1, minus 2, next to 2, minus 2, 1. Okay, this you got A. Next what I'm doing means I need the A transpose. So A transpose, listen here everyone. This A is there, this transpose you have to do. What is a 1 by 3 transpose? What is a 1 by 3 transpose?
3.
No, that is
3.
yes.
3.
Okay. Wait a minute. Mute that. Mute. 1 by 3 transpose is a 1 by 3 only. So don't write 3. what is the property of transpose? Means, for example, k into a transpose is there. This k is some number. K is some number. So it is nothing but k into a transpose. K is a scalar. Scalar means a number. A is a matrix. So k into a whole transpose is a k into a transpose. So not 1 by k. Okay. Based on this, 1 by 3 transpose is 1 by 3 only. Don't make 3. If you make 3 means your answer will go wrong. So now, next what you have to do? This matrix transpose. So 1 by 3 transpose, 1 by 3 only. Now we have to do this matrix transpose. 1, 2, 2. This 1, 2, 2. Write in column. 1, 2, 2. Second row, 2, 1 minus 2. Column, 2, 1 minus 2. Third row, 2 minus 2, 1. 2 minus 2, 1. So now you got the A matrix you got and A transpose you got. Next what you have to do? Can anyone? We got A transpose. Now what you have to do?
Multiplication.
A into A transpose.
Into A
Yes,
transpose.
very good. So now you have to do
into A transpose.
A into A transpose. So now what I am doing is 1 by 3 into, what is the A matrix? 1, 2, 2, 2, 1 minus 2. Next, 2 minus 2, 1. I'll check it. 2 minus 2, 1. Yes. Next, 1 by 3 into 1 by 3 into A transpose matrix. A transpose matrix is a 1, 2, 2 is to 2, 1 minus 2. Check it. 1 by 3 into 1, 2, 2, 2, 1 minus 2. Okay. Next, 2 minus 2, 1. 1, 2, 2, 2, 1 minus 2, 2 minus 2, 1. Next, 1 by 3 into 1 by 3, 1 by 9. Okay. Next, this 1, 2, 2, 2, 1 minus 2, 2 minus 2, 1 into next 1, 2, 2, 2, 1 minus 2, next 2 minus 2, 1. Okay. So now we have to multiply these two matrices. If anybody don't know matrix multiplication, no worry, you can learn from here. So now 1 by 9 into 1 by 9 into row into column. Okay, first row into first column. So 1 into 1, 1. Next 2 2s are 4. Next 2 2s are 4. Okay, next I'll do one thing. Wait a minute. Next, second row into, sorry. First, what you are completed? First row into first column. Next,
second column.
first row into second column. Okay. Now 1 into 2, 2. Next 2 ones are 2 ones are 2. Next 2 into minus 2 minus 4. Next, first row into third column. Third column you have to do 1 into 2, 2. 2 into minus 2 minus 4. 2 ones are 2. Okay. Next, we erase this. If anybody don't know, learn matrix multiplication from here. Next, second row into first column. Second row into first column. 2 ones are 2. Next, 1 into 2, 2. 2 into minus 2 minus 4. Okay. Next, second row into second column. So 2 to 2s are 4. 1 into 1, 1. Next, minus 2 into minus 2 plus 4. Next, second row into third column. So now 2 2s are 4. Next 1 into minus 2, minus 2. Next minus 2 into 1, minus 2. So now second row into columns completed. Next we'll come to the third row. To avoid confusion, I'll erase this. Wait a minute. If anybody don't know matrix multiplication, you can learn from here. Next, third row into first column. 2 ones are 2. Minus 2 into 2, minus 4. Next 1 into 2, 2. Next, third row into second column. 2 2s are 4. Minus 2 into 1, minus 2. 1 into minus 2, minus 2. Okay. When you are doing problems, matrices, you need patience. Okay. So next, third row into third column. So 2 2s are 4. Next, minus 2 into minus 2, plus 4. Next, 1 into 1, 1. So it is a matrix multiplication only. I know everything. Don't think like that. Everything you do with cool mind and carefully. So now we'll try to its value. 1 by 9 into, to make different color, 1 by 9 into 1 plus 4 plus 4, 9. 4 minus 4, this is 0. Plus 4 minus 4, 0. Next 4 minus 4, 0. 9. Next this value 0. Next 0. Okay. The 4 minus 4, this also 0. So 9. So what you got, 1 by 9 into 999, 900, 090, 009. So now we'll come to the next page. A transpose equal to 1 by 9 into, wait a minute, 1 by 9 into, what you got, 900, 090, 009. Okay. So now multiply 1 by 9 inside. We have to multiply to, otherwise we do one thing. Take 9 common. 1 by 9 into 9 into 9 common, what will get? 100, 010, 001. So 9 get cancelled. So what is that? What is this value? 1000, 010, 001. What is this value? Can anyone say?
I.
Identity. So A transpose equal to identity. So now next we have to do A transpose into A also. So but what I'll do means, most of the problems ఎలా ఉంటాయంటే ఒకసారి ఇక్కడ చూడండి కేర్ఫుల్ గా. Can you observe what is a matrix? 1 by 3, 1 2 2, 2 1 minus 2 1 minus 2, 2 minus 2 1. A transpose is also. Can you observe A transpose? Is there any difference between them?
No, sir. Same.
Yes.
Both are same.
Same.
Yes,
So
sir.
when both are same, no need of doing A transpose A. Similarly, we get A transpose A is equal to identity. Therefore, A transpose equal to A transpose A is equal to identity. Therefore, A is a what? Can anyone say? A is a
Orthogonal matrix.
Orthogonal matrix.
Orthogonal matrix.
orthogonal matrix. So why I am not doing A transpose A?
Both are
A
similar.
transpose,
A
both
and
are
A
same.
transpose are same.
So A transpose is enough. Why? Because both are same. Similarly, we get A transpose A. Therefore, A is orthogonal. So most of the problems is most 99% problem A transpose is enough. Why? Because they will be as it is same. If they are different, you try to do it, but not according to my experience. You won't give like it. If any they are the different means, they will get mostly not orthogonal. But anyhow, if A transpose are the same matrices, it is one time A transpose is enough. If A transpose are different, you have to do A transpose and A transpose A also. This is about the orthogonal matrix, how to check the orthogonal matrix. So from these two topics, one is a compulsory in the final exam. This is about the today's class. Have any doubts on this? Can anyone?
No, sir.
No, sir.
No, sir.
No, sir. No, sir.
No, sir. No, sir.
No, sir.
Wait. I'll stop.